Today we are going to learn about mastering custom datasets in PyTorch. We will explore how to create and utilize custom datasets, focusing on efficiently integrating them into your machine learning projects. Welcome to our video on mastering custom datasets in PyTorch. In this video, we'll explore how to create and utilize custom datasets, which are vital for handling non-standard data formats and machine learning workflows. Understanding how to efficiently construct and integrate these datasets into your projects is crucial for optimizing performance and handling complex data types. We'll begin with an introduction to the PyTorch Dataset class, followed by a detailed step-by-step guide on creating custom datasets. By the end of this video, you'll be equipped with the skills to implement custom datasets and troubleshoot common issues. Let's dive in. The PyTorch Dataset class is a core component designed to handle and manage data efficiently. It serves as an abstract class that allows you to customize how data is loaded and preprocessed. This flexibility is crucial for dealing with various data formats and complexities. By extending the dataset class, you can define how data is accessed and processed, which is particularly useful for non-standard datasets that don't fit typical formats like images or text. The dataset class works seamlessly with PyTorch's DataLoader, enabling efficient data loading and batching. Understanding this class is fundamental to creating your custom datasets, as it provides the structure needed to define data loading logic. In this block, we'll explore the characteristics and capabilities of the dataset class, setting the foundation for our custom dataset creation journey.
Custom datasets are crucial for handling non-standard data formats that are often encountered in real-world scenarios. Unlike standard datasets like MIST or ImageNet, which are pre-processed and stored in conventional formats, custom datasets allow you to define your data handling and pre-processing logic. This flexibility is essential for tasks that require unique data structures or complex pre-processing pipelines. By creating custom datasets, you can ensure that your data is loaded efficiently, minimizing bottlenecks during training and inference. Additionally, custom datasets enable you to implement domain-specific transformations and augmentations, which can significantly enhance model performance. In this block, we'll delve into why custom datasets are important, focusing on their ability to optimize data loading and improve the overall efficiency of your machine learning workflows. Creating a custom dataset in PyTorch involves defining a new class that inherits from the dataset class. The first step is to implement the _init_ method, where you initialize your dataset and any necessary parameters or file paths. Next, you'll implement the _len_ method, which returns the number of samples in your dataset. This method is crucial for the data loader to know how many batches to create. The _getItem_ method is where you define how a single data sample is loaded and returned. This could involve reading from a file, applying transformations, or extracting specific data points. Once these methods are implemented, it's important to test your dataset to ensure it loads and processes data correctly. In this block, we'll walk through each step in detail, providing code examples and tips to help you create a robust custom dataset. The _len_ and _getItem_ methods are essential components of any custom dataset. The _len_ method simply returns the total number of samples in your dataset. This information is used by the data loader to determine how many batches to create during training or evaluation. The _getItem_ method, on the other hand, is where the real magic happens. It defines how individual data samples are accessed and returned. This often involves reading data from files, applying transformations, and ensuring that the output is in a consistent format suitable for your model. In this block, we'll focus on implementing these two methods, providing practical examples and best practices to ensure your custom dataset functions correctly and efficiently. The DataLoader class in PyTorch is designed to load data in batches, which is crucial for efficient training and evaluation. It works seamlessly with custom datasets, allowing you to batch data, apply transformations, and parallelize data loading. This is particularly important for handling complex data types that require preprocessing or augmentation on the fly. The data loader can also shuffle data, which helps in reducing model overfitting. In this block, we'll explore how to use the data loader with custom datasets, focusing on tips and tricks to optimize performance and handle complex data efficiently. Handling complex data types is a common challenge in machine learning, especially when dealing with non-standard datasets. These can include multimodal data, hierarchical structures, or domain-specific formats. Custom datasets in PyTorch provide the flexibility to define custom pre-processing pipelines and efficiently handle these complex structures. By leveraging the power of PyTorch, you can integrate complex data types directly into your models, addressing unique data challenges and optimizing workflow efficiency. In this block, we'll explore strategies for handling complex data types, providing practical examples and insights to help you manage diverse data formats effectively.
Debugging custom datasets can be challenging, especially when dealing with complex data types or pre-processing pipelines. Common issues include data mismatches, incorrect transformations, or inefficient data loading. It's important to implement debugging strategies to identify and resolve these issues effectively. This can involve checking data integrity, validating transformations, and ensuring consistent data output. Optimizing data loading is also crucial to prevent bottlenecks during training or evaluation. In this block, we'll explore common issues that arise when working with custom datasets and provide practical debugging tips to help you improve code robustness and performance.
Optimizing performance is crucial for ensuring that your custom datasets work efficiently within your machine learning workflows. This involves enhancing dataset efficiency, optimizing data loading, and implementing caching strategies to reduce pre-processing overhead. By focusing on these areas, you can maximize model performance and ensure that your data pipeline runs smoothly. In this block, we'll explore best practices for optimizing performance, providing actionable insights and techniques to help you enhance the efficiency of your custom datasets and improve overall workflow productivity.
In conclusion, mastering custom datasets in PyTorch is a vital skill for handling non-standard data formats and optimizing machine learning workflows. We've explored the importance of custom datasets, how to create them, and best practices for optimizing performance. By implementing these techniques, you can enhance data handling efficiency and improve model performance. We encourage you to experiment with creating your custom datasets and continue exploring the vast capabilities of PyTorch. Thank you for joining us in this learning journey, and we look forward to seeing how you apply these skills in your projects.